Magic Hexagon in Trigonometry. This is also called as Super Hexagon. This hexagon will help us to recollect different trigonometric identities. First, we'll see how to construct this hexagon. Hexagon means a six-sided polygon. And in trigonometry, we have six different ratios like sine, cosine, tan, cot, secant, cosecant. If we observe this, sine, tan, and secant can be written towards the left side of this hexagon. Towards left, we have three vertices. So all the ratios which don't have co in front of the names will be written towards left in an order like STS. We will maintain that order like sine, tan, and secant. But before that, we'll write 1 at the center of this hexagon. Now write sine, tan, and secant. Horizontally on the opposite vertex, that is towards the right, for sine, we'll write cos, tan, cot, secant, cosecant. This hexagon, we'll see how to use this. From the hexagon, first we will try to identify the reciprocal identities. For that, check the elements present on the diagonal of this hexagon. So let us take the first diagonal here. This is the diagonal. Sine 1 cosecant. So when we consider the vertices sine cosecant, the product of these two will give 1 as the result. Or we can tell that sine and cosecant are reciprocal to one another, which means sine is equal to 1 by cosecant or cosecant is equal to 1 by sine. Let us consider another diagonal. In this diagonal, cos and secant are on the vertices, which means cos into secant is equal to 1 or cos and secant are reciprocal to one another. From that we can write cos is equal to 1 by secant or secant is equal to 1 by cos. Consider the next diagonal, that is with tan and cot. For tan and cot also, we will get a similar relationship. Tan into cot is equal to 1 or tan equal to 1 by cot or cot equal to 1 by tan. Now for the same hexagon, we can write the quotient identities as well. We'll see how to do that. Quotient identities can be written in two different ways. Either we go in a clockwise direction or anti-clockwise direction. First, let us look into the clockwise direction. We already know that tan equal to sine upon cos. So we'll start with that. So and we'll identify how to write. So here is the tan. Tan equal to sine upon cos. In similar way, we will follow the clockwise direction to identify different identities here. The next we'll take sine. Sine equal to cos upon cot. We'll write that sine equal to cos upon cot. Now if we start at cos, then we'll get cos equal to cot upon cosecant. Now start with cot vertex. Going clockwise, cot equal to cosecant upon secant. And the next is cosecant vertex. Cosecant is equal to secant upon tan. And the next is secant vertex. Secant is equal to tan upon sine. So these are quotient identities when we go in clockwise direction. Now if we go in anti-clockwise direction, they give a different identities. And for anti-clockwise, from the figure we already know identity that cot equal to cos by sine. So we'll start from that. So here is the cot and then we have cot equal to cos upon sine. So we'll go that side. It's an anti-clockwise direction. Next vertex is cos. So we'll write for that. Cos equal to sine upon tan. Similarly for sine, sine equal to tan upon sec. Next for tan, tan equal to secant upon cosecant. For secant, it is cosecant upon cot. For cosecant, it would be cot upon cos. So like this, we can write the quotient identities with the help of hexagon. And the next thing we can do with this hexagon is to write the Pythagorean identities. For the Pythagorean identities, check the triangles that are in gray. So we have three triangles here. For a triangle, we have a horizontal line and opposite to that is a vertex. Consider the triangle first one. Here we have sine and cos as the two ends of a horizontal line and one on the opposite vertex for it. So we'll write here as sine square plus cos square equal to 1. That is the first identity. In similar way, we will follow for the rest of the triangles. Now if we see this, 1 and cot are on the ends of a horizontal line. So 1 plus cot square theta equal to cosecant square theta. For the next triangle, tan and 1 are on the ends of a horizontal line. So 1 plus tan square theta equal to secant square theta. In this way, we can recollect the Pythagorean identities. And the next thing we can do with this is to identify the product identities. How to write the product identities is, consider any vertex. Try to check the adjacent vertex for that particular one. And we can write the identity. We will see here. I will take this sign. For this sign, the adjacent vertices are cos and tan. So sin theta can be written as tan theta into cos theta. In similar way, if we take the cos vertex, we have sin and cot as adjacent vertices. So cos theta is equal to sin theta into cot theta. Similarly, for cot theta vertex, cos and cosecant are adjacent. So cot theta is equal to cos theta into cosecant theta. For cosecant theta vertex, cot and secant are adjacent. So cosecant theta equal to cot theta into secant theta. For secant theta vertex, tan and cosecant are adjacent. So secant theta equal to tan theta into cosecant theta. For tan vertex, sin and secant are adjacent. So tan theta equal to sin theta into secant theta. These are the product identities. In a similar way, we can write few more identities also. That is, for this, check diagonally. When we have this diagonal sin 1 and cosecant, we can write sin into cosecant is equal to 1. And for the next diagonal, cos into secant is 1. And for the last diagonal, we can write tan into cot equal to 1. These are the three identities which make 1 as a result. Coming to this hexagon, the next thing is co-function identities. Co-function is check the vertices that are horizontal. Like sine and cos, they are horizontal. We have a relation like sine theta will be equal to cos of 90 minus theta. That cos theta can be written as sine of 90 minus theta. Similarly, tan and cot are in a horizontal line. So tan theta can be written as cot of 90 minus theta, or cot theta can be written as tan of 90 minus theta. At last, we have secant and cosecant. Cosecant theta can be written as secant of 90 minus theta, or secant theta can be written as cosecant of 90 minus theta. In this video, we have seen how to use the magic hexagon or super hexagon to recollect different trigonometric identities like reciprocal identity, quotient identities, Pythagorean identities, product identities, and co-function identities.